Hey guys, this is Brajesh. Have you ever wondered when you want to try multiple iterations with your data, or if you want to build a number of models, it would take a huge amount of time to execute, and every iteration would start only after the completion of its first one. So, our systems would only use single core for execution of any task, and that's where multiprocessing would come in handy. So, if we can somehow utilize all the cores of our system, we can reduce the execution time immensely. So let's see how we can implement multiprocessing in Python. So I'm importing a package called multiprocessing here, and I would be building a random forest model which would require sklearn, and I also need pandas and numpy for pre-processing. So let's import all these packages. So I'll be working with a sample bank data here. So let's read the file, and you see a lot of columns here. So I've chosen a specific column called p outcome, and it has four different categories. So let's come to the next part. I have defined a function here which takes two parameters. One is the input data and the other one is a filter. So what I'm interested here is I am going to filter the data for all these four categories and build a random forest model for each of these categories. So this way I'm going to show you how much time it takes to execute for each of these categories, and so that we can differentiate the execution time for when we use one core versus two cores. So I'll be filtering for each of these categories here, building a random forest model, and to also predict the results for the test data, and I'll be returning the final data frame. So I have also defined an empty list here, so that for each of these categories I'd be storing the results in this list called results. So that is something that I have defined as a separate function here, which I would be calling as a callback. So I'll also explain you that in a while. So you see that the number of cores that I have in my system is 2. So I'll be comparing the results or the execution time when we use 2 cores versus 1. So let's first try to compare the result when we run with 2 cores. So this is how you initiate the multiprocessing, and what I'll be doing here is iterating through all the different categories of p outcome variable, and then what you see here is something called apply underscore async. So this is something similar to our apply function in Python. It's just that this function call would return immediately after the execution. So it would not have to wait for the entire result to get executed. So it takes argument which where you will be passing the input data, and then you also have something called as callback. So a callback gets called every time when the execution of this function gets completed. So in the first iteration, you would call process data function, and once this function gets executed, the callback would immediately get executed. So this would store the results in this list called results. And once all the iterations are completed, you would be storing the results in a data frame called df. So let's execute this and see how much time it takes. So you could see that two iterations had started simultaneously, and it took almost 2.25 seconds. Now let's try to reduce the number of cores to 1 and execute this. So you could see that for each of the categories the iterations started after the completion of the first one, and it took almost 2.75 seconds. Now this is just a small data that I have used, so you could not find a major difference, but still you could see that it has improved by 0.5 seconds. So when you are trying to execute multiple iterations, that's when you could find a major difference here. And I am also going to show you the final output here, where I had actually got the predictions, and for each of the outcomes I've appended the data, and I get the result in the form of a data frame. So this is how you implement multiprocessing in Python.